kind of talk is just kind of designed to be a basic introduction to using LaTeX or LaTeX, however depends you pronounce it, just to write basic scientific manuscripts. I'll start off talking about why you might want to use LaTeX, why you might not want to use LaTeX. Then I'll go about some of like the basic examples of things you'd want to do in LaTeX, things that make LaTeX different from a word processor, how to do citations in LaTeX, and then just kind of like some little tricks. And if you want to do more custom stuff, there's the internet or me, and there's plenty of flexibility with using LaTeX. So basically, what is LaTeX? It's a free new public license document preparation system that compiles manuscripts using a markdown language. It's often used for scientific communication and publication. It's been in existence for 30 years. If you take a LaTeX file from 30 years ago and run it today, it will still work. You can't do that with a Word or Corel WordPerfect document that you had in 1990 because it kind of uses just like basic text and basic files to compile a manuscript. And it's also typographically a lot better than a word processor. It has superior typesetting, a better appreciation for aesthetics, and it's easier to read. So for example, LaTeX uses kind of proportional spacing between characters, whereas a word processor uses monospacing. It's harder to read. LaTeX things just look better and are often easier to read. It's what publishers use most of the time when they're publishing books. So the question is, why would you want to use LaTeX if you have something like Microsoft Word? It's great if you have to change formats. So if you need to reuse a publication for a dissertation chapter or convert your dissertation into a publishable format, you get to revise and resubmit, you send something to another journal. Instead of doing all these finicky things that you would have to change figure legends or titles or citations or formatting stuff, you can just change the code slightly and it'll automatically change all of that. Most journal publishers have to convert your Word document to LaTeX because LaTeX is what they use to put things in print. Doing it in LaTeX gives you more control over the final product, and it's less likely that there's going to be errors when they're converting it to the proof. And speculatively, I could imagine it might decrease time between acceptance and publication because it's one less step they need to do to get things printed. And it's also really flexible. Like R, you can edit your code and use packages that allow you to make LaTeX do exactly what you want. Other reasons to use LaTeX: it's stable, it's free, uses text editors, files will be editable in the future, and you don't have to worry about cross-platform compatibility. So if you're working with people that use Ubuntu or Mac or what's the third one? Microsoft. They all work. The one I don't use. They all work. It works the same across all platforms. You're not going to have those issues. It's excellent if your manuscript has lots of maths or equations. You can also use BibTex, which is a great free stable citation manager, which we'll go into more detail about later. That's one of the main reasons I use LaTeX, is just that's now my citation manager, even if I write a manuscript that doesn't have math in it. One of the things philosophically, it emphasizes content over style. So LaTeX automatically creates a nice looking manuscript with good organizational stuff and allows you to focus on what you're writing and the content of a paper instead of worrying about formatting. Writing in non-line characters is a thing. Supportive community of advice online. Like if you ever searched R-Help on Stack Overflow, similar thing for LaTeX. And also integrates well with GitHub if you need to do version control or save previous drafts of a manuscript. Here's just kind of a rule of thumb. If your document gets really complex or really long, it's generally better to use LaTeX than a word processor like Word, because it can be really hard to do fancy things in Word, and Word doesn't work well, especially if you ever had a really long manuscript with lots of images and it just takes forever to scroll down in pages. In LaTeX, you just scroll down the text file and recompile when you're ready, so it's quicker, especially for dissertations. Why not use LaTeX? You don't have time, you hate aesthetics, social factors, which I think are a real thing. Some collaborators are unwilling to work in a new format, and we have to deal with that reality. Although there are some workarounds, you can convert to Markdown from this to a PDF document or to a Word document, which are some things I found out from some people on Twitter. If you don't foresee writing many technical documents, I wouldn't worry about it. If you need to control every graphical design of a page, don't worry about it. If your target source only accepts .docx files or .doc files, you may not want to use LaTeX, although it's good to double check with the editor or the people that actually do the typesetting, because sometimes the editor doesn't realize they have to convert it to LaTeX anyway. My advisor had a example of that, where they're just like, this is what you're going to do, and then the journal ended up switching to LaTeX. This is just an anecdote. I was working on LaTeX searching for help, and yeah, sometimes you accidentally Google image things instead of Google searching things. A lot of weird stuff comes when you search LaTeX and other words, so don't search for LaTeX help in public places. All right, so how to start with LaTeX? On your computer, you need to download a tech language and a tech editor. It's about 1 gig, or you can use something, and if you've programmed anything before, it should be easy to make the transition. And also stop me at any point if you guys have questions, especially when you get into like the actual code aspects. But with the advent of cloud computing, there's platforms like Overleaf and Share LaTeX that are often better than working offline, especially for collaborative things. And these two companies are apparently going to merge in the next 4 months. One of the things is there's fewer bugs that you have to deal with regarding document compilation. There's fewer worries about updates, more hard drive space. And especially with Overleaf, they have direct submission to many journals and preprint servers like bioRxiv, PNAS, PLOS, Royal Society, Open Science, PureJ, Scientific Advances, and like 4,000 others. And it also integrates well with GitHub for version control if you use that for code. So Overleaf, if you guys go to that link, it'll take you to Overleaf. You can create an account really easy. It's at overleaf.com. It's just the platform I've used instead of others. So if you guys have your little links I sent you, or if you're on the internet and looking at this, if this gets out on the internet, there'll be a link you can follow soon. So at the basic minimum, we talk about kind of the anatomy of a LaTeX file, what's needed to compile a manuscript. As the basic minimum, it's a .tex file, which is the extension. So that contains the text, commands, and formatting commands. If you're using citations, you have a separate file, which is just a text file called a .bib file. You may also upload the images if you have graphs or pictures you want to put into your document. And there's also additional files you may want, like a .class file or a .style file, which is important for different document classes or certain important packages like particular citation styles. For example, I can show you guys at the end if we have time. Elsevier has a .class and .style template you can download. So if you're searching to an Elsevier journal, or you can just download what they want in LaTeX, and a lot of different publishers have LaTeX templates. So okay, we'll go over basic anatomy of a text-only LaTeX document file. We'll talk about bibliography management with BibTex or LaTeX or BibLaTeX. Cover figures, tables, and also some little tricks for just like basic word processing and stylistic stuff. We can cover mathematical notations, talk about comments and collaboration, also particularly some of the differences that you can do in Overleaf, and then any resources that you guys can refer to later. So starting off, do you guys have any questions? All right. So anyway, I tweeted out to the Twitterverse about this, and I forget when I took the screenshot, but I got a ton of replies with tons of little advice and tips that people wish they used when they started LaTeX. For example, when I learned LaTeX when I wrote my QE proposal, and I didn't use BibTeX as a citation manager, which was really dumb. But every time I use LaTeX and write something and move to a new manuscript, it gets a lot easier, and I'm like, why did I do that before? But it's kind of like every model, every paper we publish, or every analysis you do, everything gets better and easier. But there's this pretty big moderate upfront investment that sometimes when you're doing it, you're like, this is a waste of time. Why am I doing this? So I'm going to try to kind of lessen that first investment. So the basic anatomy, I don't know if you guys can see this well with the darkness, but the basic LaTeX document anatomy, the first part of the package is called the Preamble. So in the very simple version, what you have is this. Can you guys read this? All right. So this first line you have is kind of this document class. So this is saying use 11-point font, and you're going to have an article. You can also make that like a letter. You can do poster presentations for conferences. You can do PowerPoint slides or slides in a different format. So there's tons of options for different documents you can make in LaTeX. Memoir is another option. You make your title. So this one would be the title of the document I'm going to write is called the assemble.latex document. And you can put your author or your authors, me and my dog for this one. And then after you set up the preamble, you type the command begin document, and that's where all the text and data comes in. Does that all make sense? All right. It can get really complicated. So like R, if you... Yeah, go back. Mm-hmm.
Oh, maybe it's about this. It can get really complicated.
Yeah.
I'm just going to tell you guys.
Yeah, so this is the basic of what you need. I think you need a title and an author. I've never tried it without, but that's just what you need to get it up and running. Like R, there's a lot of packages you can use in LaTeX that might have to do with certain graphical things you want to do, certain colors, certain bibliography things. So here, if you go through, at the very top of here, we have this. Where is the key? Mouse, it's gone. Okay. We have this document class article at the top, and then for comments in LaTeX, you'd use a percentage sign to make comments. So everything in green on here is comments. So you can annotate the code. If you use a new package, you annotate what the purpose of the package is. So this is just saying the class. Here below, I have these language and font coding. So that just helps with Babel, typographical rules, and hyphenation patterns in English. This makes foreign characters easier, like umlauts and random Cyrillic things. Math packages, graphics packages. Here's packages that you can use to help with comments or annotating from other authors. A warning told me to do this, so I added it, and I didn't feel like figuring it out. Like in R, sometimes you just do what it says. So this is coming from a moderate LaTeX expert, not a real LaTeX expert. A lot of times I'll load packages, you can comment out the packages you don't want to use, or just use it to annotate stuff. Here, example is a bibliography package, which I'll get into in more detail later. And then down here is the title and author, and then from there, you can kind of start the document. So this is kind of just all the stuff you need before you start compiling the document. Any questions about that? Okay. So here's kind of the basic structure of the body. So imagine we had that preamble, we have that begin document. There's typos in here because I didn't proofread it. But so here you can have a begin document, it says make title, so it makes the title I put in the preamble, puts the authors and the date. You can enter an abstract, which will be in fancy font. So there's the abstract. And then a lot of times the way it gets structured is you have sections, which is kind of like this introduction, section 1. And then you cite section, what you want to call the section, then you start typing your text below there. When I go in more detail, you can do subsections, so that would be this 1.1. If I want to do something even smaller, you have the subsection command, which would be this 1.1.1 section. And then at the end, when you're done typing the document, you just type in the end document, and anything that goes after that command will not appear on the document. So if you have paragraphs that you typed but didn't include in the final thing, you can just put them below that to send it to people. Or say if you just want to send someone the introduction, you just put end document after the introduction, recompile it, print out the PDF, and send it to them. So this is like the basics you need to just get the body. If you don't want those numbers, you can just put a asterisk after the section or after the subsection and before that curly bracket, and that will make the numbers disappear.
So for the make title after begin document, what is that for? Do you have to do that?
That just makes the title at the top of. Yeah, because I had in the preamble, I named the document. So like a lot of times if
you're just saying this is the title of the document, then you actually have it.
Then it's like put it there. And then like another option which I didn't talk about is, a lot of times journal articles will have long names and then short names. So you can have the main title on the document, and then at the top of each page it will have like the short name. That's another option you can do in here. Cool. Any other questions?
If we wanted to take out the lettering, what do we add at the end?
Yeah, if you want to take out a number, you put I have an example in the code I'll show you later, but you put a star after the NN section and before the curly bracket, and that will just disappear. Cool. Like a lot of times in like subsections, I take that out because it feels right, or character limitations, either or. All right. So that's just kind of the basic outline of a LaTeX thing. Go into the whole code of the example document I sent you, and we can go through each examples. But first, I'll just quickly talk about bibliographies in LaTeX. The very basic, to make a bibliography, you'll need a bib file, and we'll see an example of that in different types of bib entries later. But below is a very basic example of a BibTex entry. So this is just kind of saying. We have a journal article, and this is the code for it. So it's the COCO 2008 Parental Investment Paper. So this is kind of the shorthand referential thing you'll use to refer to that paper when you're trying to cite it. And here you have the title, the authors, the journals, the volumes, and all the information that in any conceivable citation format you might want. This is what would be included.
And do you make that in LaTeX, or is that something else?
All right, let's go to Google. I hope I don't have weird things loaded up. All right, I think I saved that. So if you just go to like Google Scholar, and we'll search Andy C and whatever his paper is that comes up. Keystone, the phenotypic, whatever. We'll just click on any journal article. So here, if you have this paper, you want to import it into BibTex, you can do this, and you get the BibTex entry off Google Scholar. That's one way. There are some risks to doing that, which we'll talk about later, because Google's not perfect. But if you
BibTex is a separate thing that's on your computer?
No, this is just in Google Scholar. So if you just open Google Scholar and search anything, or probably Web of Science, it'll have an option for like BibTex, the BibTex entry for that journal. Like you would just download MLA or Vancouver. Yes.
So I don't have the import into BibTex button.
I might have that. So click on this
And then I just get the BibTex
site.
actual citation.
Yeah, and then
so
you
I
do that.
copy and paste that into.
And then you copy and paste that into the .bib file, which is a file you create in the document. And I'll show you guys that when we get to the main document. But this is just kind of how to get a BibTex entry out. And then, for example, it's trends in ecology and evolution is pretty good normally. A lot of times, if it's better, you can go to the journal website, and some are better than others. But almost export BibTex citation, and you export it, and this is kind of a pain, but a lot of times you can just download that BibTex entry, and it's right from the journal because they make sure it's right. Google Scholar is often wrong with in-collection books and old articles, so it's good to double-check any citation you get from Google Scholar. So anyway, that's how you get the BibTex entries. And we'll go to Overleaf in a minute. I'll show you the bib file, and you just copy and paste it in there. All right. But that's just how you kind of extract them. Does that make sense?
So if you have been like reading articles and doing something like Mendeley, you have to then look for the citation separate from that?
So I don't use Mendeley, but Overleaf has a way to integrate Mendeley so you can export a bib file for a particular paper. So with Zotero, which I used and I didn't like how it worked, so I stopped. And with Mendeley, you can automatically just export your library for papers. So there's compatibility. And if you use an Overleaf account, it links automatically to Mendeley. I just haven't done that. So if you're already using Mendeley, it integrates pretty well with Overleaf, or so they say.
What about EndNote?
I'm not sure about EndNote. So
Where do you store your paper? Just like nowhere?
there's the PDFs, and I randomly search keywords or download them 6 times. But yeah, it depends. A lot of times I just name them and then keep them on my computer and then try to find them later. I really don't have a good organization file for PDFs. But like for bib files, I'll save a bib file after I write something and have the whole file, and then I'll just like copy it and paste it in there and use what I need or use what I don't need.
You have to hand edit. Like with EndNote and Word, like I just connect to the citation and it like automatically compiles the reference.
Yeah, with Overleaf, if you're using Zotero or Mendeley or a couple other things, it does that. But I don't do that because I'm a bad example of that. There are smoother entries, and I just keep copy and pasting and using things. So that's something I'm not good at, but I know that there is something like EndNote where it links to it in the back end in Overleaf. And I wouldn't be surprised if there is an on-computer LaTeX thing that does that, but I've kind of gotten stuck in my way and have to change. So I'll be upfront about that. So, cool. Any other questions? All right. So, let's do play. So there's kind of 2 main bibliography citation managers. There's BibTex. So in your preamble, what you would do is you'd say use kind of this package, which is saying use square brackets and sort and compress the numbers in the square brackets, and use the natbib BibTex package. Make your document, put your text, and then you'd put the bibliography style, so like Vancouver, Harvard, whatever, and then you would type bibliography, the name of the .bib file, and then it would automatically put the bibliography at the end of the paper. I stopped using BibTex and have switched to BibLaTeX, which is a newer thing that uses Beaver as a backend, so which is some programming thing that I don't understand. So here what you do is you can change the citation style, so it'd be like author year, change the bib style, so here's max number of names, you can make it 2 if you want to say anything 3 authors or more, it would say et al, and you can kind of just customize it to what journal style you need. In the preamble, you specify what the bib file is, and then wherever you want your bibliography in the paper, you just type print bibliography, heading equals bibliography. And I'll send this out, but we'll have the Overleaf example to go through. This will make more sense when we see it in action. But BibLaTeX is often better with like things that need URLs and computer programs if you have to set them. All right, so now we'll switch to Overleaf. You guys have that little document loaded. It's this one. All right, so here's kind of the basic does everyone have this loaded? I can see it. All right, here's the basic Overleaf template. So kind of here on your left are the files you've added. I have my main text document, which is this. And all these blue things are things that I've commented out. Here's the bibliography that I've entered. So these are the sample BibTex entries. So here's the Cocoa Perennial Investment article we found on the slide. So that'd be an article. This is an in-collection book chapter. So you have the author of the article and then the editors of the edited volume. This is the BibTex entry for an actual book, so that would be called the book. If you have an R package, like Richard's Statistical Rethinking package, this would be the BibTex entry for that. And if you're in R, I forget what the command is off the top of my head, but you can just type something and it automatically spits out the BibTex citation for any package. And also the BibTex citation for R, or that version in 2016. And here's an example of a book chapter that I cited that's wrong. So it's Triver's 1972 Parental Investment paper, which is a chapter in a collected volume, but both of the Google Scholar entries for it either said it was its own book or its own article, when neither of those things are right. So that's just kind of something to be aware of for older papers, even ones that have been cited about 12,000 times. So Google has a lot of issues with old things. All right, and then you can add your file. So here's like the stock image that comes with Overleaf in their text thing. So if you want to do files, you can just add a bib file, files from other project if you're using old bibliographies from different thing on Overleaf, or you can upload from your computer or Dropbox or wherever. All right. Does that kind of left-hand column make sense to everyone? All right. So, in kind of the Overleaf driver's seat, this is the text document, or whatever thing you have selected appears in here. Over here is a preview of the PDF compilation. A lot of times I just switch to manual because my internet's slow at home, and then I refresh the preview when I want to see what the changes I make look like. If you need to change versions of the file, you can save it and add a label to it and then open and compare old and new versions, like you can in GitHub if you use that. Here's the sharing links. This is to make a PDF of the document, and that's going to download in a second. And then this is kind of the journals and services thing, which links to other journals and services. All right. So, all right. So here we have specified in this document, we have the document class. We have these English packages which are loaded. These are packages that help with graphics and math, and have them commented for most of them what they do. This is a package that has, when I have hyperlinks, it highlights them in blue. So this also includes if I'm typing a document and I refer to figure 2, it automatically does a link to the figure so it goes back into the document. If you have a citation and you click on the citation, it'll go to the bibliography just like in a journal article. If you can also set it up where you can label a section. So you like imagine the beginning of a paper or in the middle, you'll be like, well, I'll get to this in section 4. And you can just kind of refer and have all these links click and go back and forth between things. Any questions? All right. And here is kind of this bibliography stuff. So I have this use package, and I have it site style author year. So if we go over here to the example of where I have the author year stuff, if I wanted to change this package, what I could do is comment out the author year, and then switch to the one where it is site style numeric. And if I refresh the preview, this will change to something that's more like a tree or a PNAS or a science citation style, which we'll see in a little bit. Okay. Bam. So that just changes really quickly if you need to, and then if you need to change the order of the references, it can change that very quickly as well, which I think EndNote and stuff does too. But this is just kind of convenient. So, all right. So right here we have like introduction. So you have your section for the introduction, and you can put it here. And here's some text. And if you want to start a new paragraph, you just press hit enter. If you want spaces between your paragraphs, just make sure there's an empty line between them. It's generally kind of good to be consistent. So if I kind of deleted this, it would just make the line disappear between different paragraphs. All right, and if you want to talk about some kind of just basic editing differences from word processors that kind of makes LaTeX frustrating at first, but are pretty, you get used to once using them. So LaTeX nerds call like Word what you see is what you get processors. So unlike them, you need to kind of tell LaTeX to do everything. So this includes all formatting stuff. So if you wanted to, make this disappear. So if you wanted to italicize, you have to highlight something or type in the command text.it, and in curly brackets you put the text you want italicized. Same thing for making things bold. Text.bold \textbf is, you kind of see this code converts to here. If you want to make the text size smaller or larger, you wrap these commands around the texts, and then you can kind of see how this is a font size smaller, and this is a font size larger than the rest of the document. So this is what you need to do to change text sizes or text formats from what is specified in the preamble. It's just like highlighting. And you can also, in Overleaf, you can just highlight it and press bold or italicize like you would in Word. There are some other quirks. So some keys and symbols need to be coded explicitly, including ampersands. So instead of typing an ampersand, it uses that as code, but if you want to type that, you need to do a backslash. Ampersand, same thing for a percent sign. Ampersands are used in tables, percent signs are the commenting notation. Also, quotations are a little bit different. So instead of doing quotations, you have to do 2 accents and then 2, I used to call them air commas when I was little, and I didn't remember what they were actually called. Apostrophes. If you want quotations around things, because different stylistic things of publishing use different quotation norms. All right, so that's kind of this basic. Does that all kind of make sense? But this seems like a pain a lot of the time, but you get super used to it once you start working in it. If you want to add lists, you can make lists with automatic numbering. You can also use this to make outlines if you want. Although I would imagine this is a little burdensome to use with outlines, so I wouldn't. So for example, if you wanted to make a number list, you'd have this begin enumerate command and an end enumerate command. And everything you wanted enumerated, you would call an item, and then write the text. Same thing for bullet points. You'd have a begin itemize, an end itemize section. Then each thing you want bulleted, you would say item and then space. So does that kind of make sense to everyone? And then this code turns into this on the PDF.
What if you want a bullet within a bullet?
There are ways to do that. I don't know them off the top of my head, and I didn't put them in the example. So you're talking about like in an outline kind of way? Yeah, you could probably do a tab command, but this is one of those things where I'm sure someone's written a package that makes making outlines like that easy. So like for a final document, I feel like you might be less likely to do that in like a manuscript, and like if you're just making an outline, I would just do it in Word, because that's a place where it's probably easier, because it's not that complex and it's not that long a lot of the time. All right, and if we want to look at like BibTex citations, we talked about how you can change citation styles. But if you are, and then having the bib entry, you need to have that bib file set up in the Overleaf file, or if you're using a computer, in the same folder as your text file. So we talked about how to get entries with Google Scholar, and apparently this does have some compatibility with Mendeley and a couple other citation managers. I try to use BibTex with papers. Have you guys ever used that? I think it went out of business, but it was like an iTunes library for scientific papers, and I paid for it, and it just was terrible. It I don't know. This is free, and like things like Mendeley and Zotero, like I don't know if they're going to be around for another 10 years. EndNote and LaTeX, BibTex have seemed to be the only things that have stayed around. All right.
But they're doing different things, right?
They're both citation managers.
But Mendeley more than just a citation.
Oh, sorry, I was correct. Mendeley is more than a citation manager. I think I was making the comparison between EndNote and BibTex.
Okay.
So, but yeah, Mendeley, people love it. I just haven't used it.
What does BibTex look like outside of LaTeX?
It just looks like a text file.
So there's no, like, I guess I'm just sort of confused.
This is like the interface of BibTex. Yes.
Yeah.
Okay.
So BibTex is it's just a .bib is the extension.
And I think this is where you manage the different BibTex files.
So like BibTex is just storing all your citations.
Yeah. So
But I haven't.
So each of these are a BibTex entry, and the file with BibTex is a way to just BibTex in a LaTeX document. BibTex is a citation thing that takes the entries from the bib file and you can cite them. BibLaTeX is another interface to take entries from a bib file and cite them in the paper. A .bib file is just essentially a text file with these bib entries, and by calling it a .bib file, it communicates with BibTex and BibLaTeX to cite everything.
So you don't use BibTex then? You just keep everything in text files?
Yes, and I shouldn't. That's a bad habit of mine, which I think I wrote about.
So BibTex would be like a no if you're using BibTex.
Probably,
Okay.
yeah.
I just got it. EndNote's got it.
Yeah, I think there might be. I'm just not keen on it.
I feel like if it interfaces with Mendeley and LaTeX,
Yeah.
Okay.
but I don't know how it interfaces with Mendeley.
But you know how like Mendeley you can export a bibliography like really quickly there into a Word document.
Yeah.
Like I bet it just does that, but in this format. I would assume because it's
Yeah.
it's like storing all that information, including PDFs.
Yeah, it just
Must
exports the bib
store.
file because it's all this like metadata kind of stuff.
But it probably has the same things where it would for old papers and books where I
Where it
find
messes
up.
Mendeley messes it up all the time,
Yeah.
and then when it's messed up, you realize it and you need to go back.
Yeah, the advantage of this is if you're citing a lot of the same stuff a lot of the time, like all these things have problems, and like if you're an old curmudgeon that just holds text files, you have some control over it.
It's
But
the same with Mendeley, right? Like
yeah. I just don't know about Mendeley because I
Yeah.
haven't used it, so it might well be. All right, so here's an example if you want to do in-text citations. So let's close this again to make it bigger. Where do I have? I have an example somewhere in here. Okay, so here we have the sentence where it says, one flaw of Trivers et al., and we changed it to parenthetical citations. Original parental investment theory was ignoring the Fisher condition that a parent is equally likely to birth one male and one female. So if you look into here, having this if you're typing in LaTeX and you want to use a citation, doing like \cite p, and then it will show the list of all of the BibTeX entries, and then you could just search, start typing Coco, but this is what we want, and we can click on it, and then you add that. If you want to add a second one for a list of them, you can just go and click on the second one, and a third one if you want to make that, even though these aren't right citations. So this is how you just kind of make those citations. I commented this out earlier, so it ended up being numbers instead of parenthetical, but this cite T is like an in-text citation, so that's why it says Trivers et al., and then the parenthesis that links to the citation if you want to use the author's name in the body. But if you just want to do a parenthetical statement, you would do the \cite p. There are a couple other citation things like cite year and cite author, but these are the two you use the most. Does that make sense? Kind of those commands? Right. Any questions about that? So yeah, pretty much if you have a bib file and you have the BibTex code set up, and when you're typing, you just cite \cite, and then the list of everything comes through, which is kind of like EndNote and Zotero, I think. Or I think it's like EndNote. Right, so that's kind of the gist of just using bib files. And if you guys want to go through here, and I had more blurbs. So if you want to use figures, first thing you have to do is in Overleaf, or if you have it in the same file, if you're using an on-computer document. I think I just do project, yeah. You have to upload the image file, so you have this frog.jpg, it can be a PDF or a PNG file, to the computer using the upload link in the project menu. And then there is this include graphics command, which is here. So right now, if we want to like walk through this code, have these commented out so I can delete them. This says begin figure. This thing is a float specifier, so it kind of tells you where in the document you might want or not want the figure to appear. You don't need this, but oftentimes it's useful to have it. H means here, which is having it closest to where the figure's first mentioned in the text, and T is like at the top of the page, and you can use them in combination, and there's a ton of them. So you want a figure, you do something like begin figure here, have it for centering the image, then you'd say include the graphics. Here's the file name of this frog.jpg, and then if you want to have the width, so this is saying make it like 30% of the text width of the document. If you made this like 50, it'd be larger, or you could also put it in inches or centimeters with whatever width of, however large you want the image to be. And then you have your caption, so then this would say the caption you want in the figure, and it's going to automatically number each figure and table based off the order that they appear in the document with being mentioned. And then this label thing is a label you give each image or document or section that if you want to use it in text and you're adding figures or taking them away, it automatically renumbers everything. Say if I had 10 images and then for the final paper I could only have 8 of them, if I just deleted the other 2, LaTeX would automatically update all the in-text references to those figures and tables, and you wouldn't have to go back and renumber everything. So, and if I want to do it in text, so here it says see the code for figure, and then I do this \reference. So if I type this again, just like in BibTex citation, in BibTex things, I can click on figure frog, and then in text it will say figure 1.
So you're always writing figure colon and then the name of whatever.
Yeah, it's just a shorthand so you know what it is when you see the list. And then the floats are the things you can do if you want things to move around. So if I were to do this and refresh it, this is going to go to the top of the page where figure 1 first appears in text. And then I have some links in here for citations about floats and figures and captions. All right, is that any questions about that? Okay. How to add tables. So tables, I think, are the one thing that can be a pain, especially if they're large, but you kind of get used to them. The one thing I find really useful is a tables generator. And just another little LaTeX key here is you can kind of see that I have this online LaTeX table generator. So the way I've specified this is it's a link. So you click on the PDF and it will take you to the website. And here's kind of just some kind of code you can use to embed clickable links for PDF. For it'd be like the hyperlink thing in Word, but this is so you can link to an external website in the document. So you have the web address here and the text in the second part of these curly brackets with its href command. So what I do oftentimes, we have R output for parameter estimates of models. I'll make a CSV of the text I want to appear, and then like these things were a pain at first, but I've gotten used to it. And then you can go to this online thing called the LaTeX table generator. There's a bunch of different ones. You can import a CSV file, paste table data, or load stuff, and then from here you can format it to be whatever color or have different kinds of lines you want. Merge cells, not merge cells, so like here we could just add shift. I could just add a line there if I wanted it to look like that. And then you click on this generate thing, and this will generate LaTeX code. You can copy it, and then you can paste it in the document, and then that's the code for the table you want. I would only use table generators because coding a table from scratch is a huge pain. What else is there? Overleaf. So here's an example of kind of a basic table that comes in LaTeX where you have this begin table command, you center it, and you begin this tabular thing. So this is saying left justify, right justify these columns. These ampersands are separating each column, and then these double backslashes say that's the end of a line, start a new row. And then this is just kind of code for a simple table. And this is code for kind of this fancier table where we have a bunch of entries and mathematical notation in the titles. But you can look at that later if you want to see what the code, and it's kind of intuitive if you just look back and forth and see where on the table corresponds with each little different thing in the code. And like I said before, you can label each table. So this is label table global parameters. So if I wanted to reference that here, I would do \ref, and then I could click on that, and then the table number would appear in the document. So that's kind of the basic gist of tables. Do you have any questions about that? Okay. Then lastly, adding comments. So this is kind of one of the things that took a little bit longer for me to figure out. So there are a bunch of different ways to comment on projects and working with other people. Because one of the things with Overleaf is you can collaborate with multiple people. Multiple people can have access to the same project and make edits, but sometimes it's kind of hard to know who's saying what, which is something we were talking about earlier in the week. So for example, in Overleaf, one of the advantages is it has these two kind of views, the source code view, which is what we've been looking at, and then the rich text view. So if you're working with someone who's not used to Overleaf or not used to LaTeX, this rich text one is more similar to like a blog or a Word document. So it's a lot better for people who are new to LaTeX or when you're working in kind of the natural LaTeX comment mode. So for example, here, if I wanted to make a comment here, say you can close, and then I could go to this comment box, and I could say like, can I really? And then here it's kind of nice in that it highlights the text you highlighted, like kind of in track changes in words. You can put your comment on there, and then I could reply. There we go. That's weak, anyway. But yeah, you can kind of just do all these edits in Overleaf to kind of talk with collaborators about certain aspects of the document. So this is kind of something that's unique to Overleaf if you use this little box and add them to the documents. But there are a couple other ways that you can edit things. So here, if you want to have comments to the margins of the PDF, you can use this to-do command. And then you can have an inline comment. You can use this to-do command, which will put a comment in the margin. If you put it right after here, so it says to-do command, and then you have this code here, and then that puts this line here in orange to a comment you would make. If you want to, in the preamble, a bunch of people recommended this. You can, like, I made a code in the preamble called Brendan, and it added this comment, but you could feasibly do it to in-comment things, so each author can have a different color for their comments, but you would just go up to the preamble of the document and specify a command like you do in R if you're saving a function. So this is just kind of saying, make a new command that has all comments I have in italicized green. Put that in text. But you can do that for authors on the side. Back to rich text. So yeah, you can do these side comments if you don't want to use the comment feature in Overleaf, which I think is actually pretty good. And the comment feature in Overleaf puts parenthetical or parenthesis signs for normal LaTeX annotation in the document, so it still all gets saved in the document. And this is kind of just another way that's in some ways better visually in the final PDF if that's your goal. Where are we? All right, we have about 5 minutes left, so I'll try to quickly go over maths. So do any of you guys anticipate like doing maths or writing specifics about stats and statistical models in your papers ever? So if you do, LaTeX is the best for math. It's like what all mathematicians and physicists write their manuscripts in. and almost all economists. So in some fields, LaTeX is the norm for publishing. In biology and theoretical biology, the majority of people use LaTeX. It's just nothing is better for aesthetics and editing the math. So a lot of times, if you're typesetting in mathematics, I don't want to do that. If you're typesetting in mathematics, you can do inline project. You can do inline text. So down here, you can, if you want to put inline math, where is that code? There we go. Dollar signs kind of indicate math modes. So here, if you want to say let x1, x2, blah, 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 be a sequence of independent numbers, this is kind of the mathematical notation, and that allows you, putting the math symbols and dollar signs, allows you to just throw that in the text of your paper. Here's just kind of one way to specify, if you want to specify a particular equation, like this one, this would be the command to do that. One thing I like is kind of using this code, which is using the kind of enumerate command and beginning a section where you number equations. So this is just kind of an example of a paper where I have, this is the code for the mathematical expression here, and then it sets it off, gives it a number. You can give it an expression, so if you need to refer to the equation in text, you can just reference that by number. And then here would be the second one for this equation, and it all depends on whatever particular maths you need to do in LaTeX. But if you need to do math, like LaTeX, the best way, hands down, to do it. So here's an example where it says the parameter lambda, where I have this lambda in text, and this is the code for that, in equation blah, 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 and this is the reference for that equation, and I can click on the hyperlink, and if it was a PDF, it'd go up to there, which is, it's right there. So anyway, it worked, but it didn't move. And then at the end of your document, wherever you want your bibliography, you can do this print bibliography, and then here it just prints it automatically and updates it when you add bib entries. So that's that. We have like 2 minutes, and I'll just show you 2 other final things. Any questions as I rush through that? Okay. And we can discuss if we actually want to do this on the paper we're working on in a little bit, but I figured I'd just show you guys. Couple of random resources. Yeah. So this is Wikibooks. This Wikibooks entry is just a good kind of thing to look at different LaTeX hints for how to use programming code. Other things you can write in LaTeX are cover letters, which I'll show you just a cover letter I've sent to a journal. If you need to write a rec letter for a field assistant with like official letterhead. For thesis stuff, I did my thesis in LaTeX, and it took me like 2 hours to get the chapters I'd written in LaTeX formatted for my dissertation because I had to like move supplemental stuff. And then it took me like 3 days for the one chapter I did write in LaTeX and wrote in Word with collaborators. And then Pandoc is the thing that allows you to convert LaTeX to Word documents if you need to do that for collaborators. All right, stop in a minute, but here's just kind of an example. So like this is my dissertation. This is all LaTeX code that I did on Overleaf. And you can have that all specified. And when you do this, everything's just automatically there and links to like all that basic LaTeX templates with sections and subsections automatically gets entered in a table of contents, and it was very, very easy compared to Word. And then if you need to do letterhead or something, here's like a cover letter to a journal. So you can download the template for UC Davis letterhead and add your grad group or to ESP department and send fancy letterheads to people.